In this video, we'll go over the answer to question 13 of the 2021 New South Wales HSC Chemistry Exam. The question states, a chemist synthesizes a substance using the following pathway. Then we see a process shown in an equation-like fashion. X undergoes hydration to form Y, which undergoes oxidation to form Z. The question then asks, what are compounds X, Y, and Z? Followed by a table of options. To answer this question, we will go through the possible compounds at each step and figure out which option can undergo such a process. Firstly, looking at the options, we can see that compound X is either propane or propene, or prop-1-ene. We also know there are two steps in the pathway. Step 1 being X to Y, where X undergoes hydration, a process where water is added into the molecule. Step 2 being Y to Z, where Y undergoes oxidation, a process where one or more hydrogens are lost or oxygens gained in the molecule. Starting with the first step, we need to see whether propane or propene is the molecule that begins this process. In other words, we need to see which of these can actually undergo hydration. Propane is an alkane 3 carbons in length. Like all other alkanes, it is a fully saturated, stable molecule with strong single bonds between the atoms. This means that atoms would need to be replaced if we wanted to change the chemical structure. Therefore, alkane doesn't undergo hydration or addition reactions in general. Propene, on the other hand, is an alkene, also 3 carbons long, but with a double bond between the first and second carbon. This double bond is reactive, can be broken, and additional atoms added in. The molecule is unsaturated. Therefore, unlike alkanes, alkenes can undergo addition reactions. In this case, when propene, the alkene, undergoes hydration, a water molecule is added with H and OH, the product being propanol, 2-propanol, an alcohol. This means we can now eliminate options A and B, and that molecule Y is 2-propanol. 2-propanol is a secondary alcohol, with the OH group connected at a carbon with 2 other carbons attached. As seen by options C and D, the product compound Z is either 2-propanone or propanoic acid. As the question states, molecule Y undergoes oxidation, which involves the loss of hydrogen atoms, addition of oxygen atoms, or both. When oxidized, secondary alcohols form ketones and do not oxidize further, as no more hydrogens are left on the carbon to lose. Therefore, our alcohol, 2-propanol, will end up forming 2-propanone, and that means option C is the final answer. To dig in a bit deeper into the oxidation of alcohols, we can see the pathways that occur when alcohols are exposed to appropriate oxidizers. For primary alcohols, the OH group is attached to a carbon that is only connected to one other carbon. When oxidized, 2 hydrogens are removed, one off the carbon and one off the oxygen. And the bond between the oxygen and carbon changes to a double bond, therefore forming an aldehyde. If not stopped, further oxidation will cause an overall addition of an oxygen atom to form carboxylic acid. For secondary alcohols, the OH group is attached to a carbon that has 2 other carbons connected, seen as 2 red R's representing hydrocarbon groups. When oxidized, 2 hydrogens are again lost, and the bond between oxygen and carbon becomes a double bond. Therefore, a ketone is formed. No further oxidation can occur, as no more hydrogens can be lost or oxygens added to the carbon. In our question, for the final molecule Z to be propanoic acid, Y would have to be 1-propanol, a primary alcohol. Options A and B had 1-propanol as molecule Y. However, these were eliminated when looking at the first step in the process, hydration. Therefore, option C was the only possible answer, as molecule Y was a secondary alcohol. For this video, the following references were used. Schell and Hogan have a nice section on the reaction of alcohols in general, showing that primary alcohols are oxidized to aldehydes and carboxylic acids, while secondary alcohols are only to ketones. The diagram here was used in this video. The section on addition reactions states that only unsaturated molecules like alkenes undergo these types of reactions, but not alkanes. In Blackman et al., we also see references to the non-reactive nature of alkanes and how alkenes are reactive and undergo addition reactions, such as hydration. Blackman et al. Is where the diagram on the oxidation of primary alcohols was used for this video, and we also see a discussion on the oxidation of secondary alcohols. Lastly, the website moleview.org was used to draw structural diagrams. If you have any questions or comments, please leave them below. Thanks for watching and see you next time.